Hello and welcome for those of you who have joined us already. I think there may be some who will be joining as we get started. We'll start in just a moment or two, but by quick introduction, my name is Will McDonald. I'm the head of admissions here at Constructor Institute of Technology in Schaffhausen. I'm here on campus with my colleague, Professor Dr. Manuel Oriol, who's our guest speaker today. And I'll be introducing him more formally in just a moment. As we get started, just to share with you the logistics, we will give a presentation and follow with question answer through the chat function in the webinar. If you have questions during the webinar, of course, we may have the chance to answer a few of those by typing. And then we'll take a few questions as well at the end of the session after Professor Dr. Oriol's presentation. I will also stay on the line, and I will invite all of you to stay on the call following the presentation to talk about our programs very quickly, to introduce our master programs and some of the admissions points that might be salient for those of you who are thinking about a master's degree for this year or for next year as well, and to invite you to a session that we're having next week specifically on admissions. But to get started today, just again, we'll do a quick overview. I want to welcome all of you by giving a quick introduction on Constructor Institute of Technology. I'll introduce our esteemed speaker, and we'll have a Q&A, and then I'll, again, stay with you for those interested to stay on the call following the presentation. For those of you who may not be familiar, if this is your first time connecting with us at Constructor Institute of Technology, welcome again. We are a young but very dynamic and very experienced team at the Institute. The Institute began 2019, so by young, I mean the Institute's heritage is young, but all of us, the leadership and the staff, have extensive experience in higher education. As you can see from the slides here, and I'll present more about the Institute next week at this time, but you'll see that we have several cohorts who have graduated already, one just last week, which was an outstanding graduation celebration. We have students coming from both across Europe and around the world. And one of the most important aspects of the Institute is that we began with the aspiration for being at the cutting edge in research and teaching. So research in technology and then teaching directly at the very forefront in the fields of computer science, software engineering, and quantum technologies. We're very proud of the fact that we have a strong representation of women in STEM, and we hope to continue to grow that representation. And you'll see our academic output, academic output of the faculty and the research team is really exceptional for the length of time and the number of individuals here. For those of you not familiar with Schaffhausen in Switzerland, we are, as you see on the Swiss map in the center, we're at the northern border, just surrounded by Germany on three sides, the canton itself, but the city of Schaffhausen, the village and city where we are, about 35,000 people, and just 45 minutes from the pin center of Zurich, which is the largest economic and business hub of the country, very dynamic player in IT and in innovation for Switzerland itself, and of course, as a major hub for IT around the world. I won't go into full details, but you'll be invited to learn more about why study in Switzerland, why study IT with us here. I alluded to our esteemed faculty. We have one of them present today and others coming from the top institutions in Switzerland and having very influential roles in their respective fields, both in research as well as in teaching. Many of them have industry experience, and this is key. Our esteemed speaker today also has great industry experience from ABB. And you'll see that as you read their profiles on our website, you'll understand how the Institute began at the very forefront with premier faculty, including a collaboration with the University of Geneva. So some of the faculty, a couple of the faculty there are joint appointments with the University of Geneva. In terms of research, it's an interdisciplinary team. So the areas span from software engineering all the way through to quantum and digital learning, for example. You see all of the different elements there, areas where the research of the Institute has developed. Today, we're actually pleased to have my colleague present, Professor Dr. Oriol, who is president of Constructor Institute of Technology and head of the chair of quantum software engineering. He has, as I mentioned, previous experience as a professor at other institutions. He's been at University of York in the UK. He has experience from ETH Zurich as well, I think PhD from University of Geneva, if I'm not mistaken. and has experience at ABB, leading software development teams, Internet of Things, really in innovation. So coming from academia, transitioning to industry, and then back to academia really makes an exceptional professor to lead our team and to share with you today his insights on software developers or software engineers who will lead the future. So I will gladly turn it over to Professor Auriol to continue. And thank you again for joining us today.
Yeah, thank you very much. As you could see on the picture, I grew a beard in between. I think it's okay. Tell me if I can share my screen already. Yeah. Okay. So yeah, welcome here to this webinar. I want to mention that I also gave a webinar last month. I'm becoming accustomed to it, and I like it. But this webinar was about whether AI is going to take your job as a software developer or software engineer. And then I realized through the questions that many people very often use the same name for or the two different names for the same thing. So they, especially when you look at job descriptions, sometimes they make the confusion. So they ask for software engineers when they really want software developers, and vice versa. So I think or I thought it was a good idea to have this presentation to talk about software engineer versus software developer. I guess that many of you are actually software developers or software engineers. I have no idea. But I hope we can come up with a common understanding. So let me start with having a small recap of a story that happened to me. And I just realized it was more than 10 years ago now, so it doesn't make me younger. Essentially, I was at that time I was working for a company called ABB, which is a very large industrial player. If you don't know them, it's a Swiss company, but it's global basically. And this means that we have in that company we had many different products, 130,000 people big, and a competitor of GE or so General Electric or Siemens. And then I generated this image with AI, by the way. So that's why this guy has so many fingers here. So it was 2014, and I was in the research labs. I was an expert in software testing, in software engineering, for embedded systems, but also for real-time systems and in general. And a former colleague from the research center called me and said, "Hey, Manuel, do you wanna come and work with us for like 4 months? So to do a job rotation." That was common, right? So I started to ask him, "So what is it? Well, why do you need me?" And then he said, "Well, we have this code base that is for running some stuff, some embedded system, and it's kind of old, but you know we have some quality issues." Okay. So quality being one of my main topics, then I decided to say yes, I want to see it. And I asked him a question, which was, "How many lines of code do you think you have there?" And he said, "Probably between 10 and 20,000 lines of code." And then I thought, okay, piece of cake, right? Because 10 to 20,000 lines of code, that's not a lot. I can do that in my sleep, right? And so I agree, my boss agrees that I do the job rotation, and then I start there. And then I asked the same question to the department head, "How many lines of code do you have?" And he said, "Oh, something like between 2,000 and 3,000." And I thought, oh, wait, but there's a discrepancy here, like the tenfold. And I thought, well, probably the department head doesn't know anything, but my friend who was the team leader knows everything, right? And then I asked the developers, and the developers, they said, between 50,000 and 100,000. And I was just like, okay, so basically no one really has a clue about this code base, right? And so I started to work on the code, to get the code, and then look at it. And some parts of the code were dating from the 1980s. You know, so that was in 2014. So that was end of 1980. It was like 89 or something like that. That was already 25 years ago that this piece of code had been written. And then I saw different styles in the writing. So you had different standards as to what you wrote, how you wrote the documentation, and how this was actually being put together. And I could separate three different periods. So 1980s, perfect code, very well written, comments were great. If anything, maybe too detailed. And then the 1990s, it was like a mess all over the place. They completely renounced the normal coding conventions. That was kind of very difficult to read. And then in the 2000s, they started to put back some structure, but not the same as before. So the code was really, really interesting because it was really archaeology. So I had the feeling to be this kind of character that you see on the right side, a mix between Indiana Jones and the kid from War Games. I know it's a very old reference, so Will and we know what that is. I encourage you to have a look at it. This is a reference from when I was a kid. And then the code that was there was DSP assembly code. I don't know if you know what a DSP is, but it's a digital signal processing chip. And you can code it with assembly and some C. And it had much code duplication and it contained many bugs. And it's not me who was saying that, it's the developers. The code had been written by software developers without any proper software engineer on the team for the past 20 years. And when I say this, I mean that because it was for an electrical device, for running an electrical device, the developers were actually very strong in domain knowledge, which meant electronics or so power electronics or electrical engineering. But they were not having a software engineer. Okay? And so that was the problem. That was the long-running problem that they had. And that's why I had to be this kind of archaeologist. So what did I do? And that's just to give you an idea, right? I started to explore the code, right? And to do this exploration, then essentially I started to write some file explorer that would generate tree maps showing the larger parts of the code. So I don't know if you know what a tree map is. I encourage you to have a look at it, but that's basically some kind of visual components that puts the size of the different files or components that you have in adequation with their actual size. So, and then you set weights to each of the sizes, and then you can actually browse them. And so suddenly we started to see how many lines of code there were, right? And would you believe that? There was basically 1 million lines of code. 500,000 were assembly code and 500,000 were actually C code. And so what you see there is that when you don't have a software engineer, someone who caters, who takes care of the code, you end up having very, very large code bases and no one, literally no one knows about it. So you could see that with the department head, when I showed this result, he was just like, what? We have 1 million lines of code. And yeah, well, so, but then the question is, why do you have so many lines of code? And one of the problems is anytime they had a new functionality, they would duplicate the complete code base or some big parts of the code base at least, and then rewrite some of the parts. So rewrite a few lines, or they would take a full function, then copy paste it, and then modify a few lines. And then you had a lot of very different the code duplications. So the code was duplicated, it was the same, but at very, very many different places. And they even had for each product a complete duplicate of the code base. And you had 5 products that were based on that code base. And in case you're wondering whether, because 5 products might be nothing or might be a lot, that were the 5 products that they had. So this unit was making billions based on this code, completely based on this code. Okay, and they had bugs. They had bugs because Well, when you use these assembly codes, one of the problems you have is you have a limited stack. I mean, everyone has a limited stack, but the limit was 16 calls in that stack. So if you understand, it means that a function could call a function, could call a function, and this only 16 times. And if you had more than that, then you would have a crash. And so you needed to understand what was the maximum depth of the call stack. So that was one of the analysis that I ran with a custom-made static analysis tool, because guess what? When you have assembly code, there's no static analysis tool for them if it's not x86 or 68K, period. So I made a full parser for the code, a full static analysis to discover the depth of the code stack that you could have. That was one problem. And another problem was the extensive use of interrupts to switch between different places. And when you switch between different places, some parts of the stack can actually get corrupted. And you need to know exactly when you can switch and when you prevent the interrupt from happening. So you need to establish critical sections. And since the developers were really good in electrical engineering, they didn't understand that very well. And so they had left really a lot of functions in a state where you didn't know whether you could be having an interrupt or not. And actually, in many cases, you couldn't. So that was the context switching. And finally, and that was that was the two parts. The first part was to try and find bugs, so running some static analysis. And the second part of my assignment was to start having a regression testing server. And because this is an embedded system, this is a cyber physical system, then it's very difficult. And they had an engineer who tried for a year to do it using the wrong technology. And so because I knew some of the technology, I installed the right kind of servers, and then I connected it, and then suddenly they had a running test suite. Not many test cases, but it was in place so that they could add many of them. And slowly, the team regained control of the code. Slowly, little by little, right? And they made a jump in quality. And then at some point, they realized that the code was difficult to maintain because they still had a lot of code duplication. So going into that level of details and understanding that it would be difficult to port that to a new chip made them actually switch completely the code base. So after 25 years and 1 million lines of code, they threw away the code base. However, they didn't throw it away right away. They needed still to be able to do maintenance. And the maintenance is what is killing you. It's killing your results because maintenance is a cost. It's a pure cost. So if you have bad quality, you have a lot of maintenance to do. Okay. So, and this is what happened. And this showcases the difference between a software engineer and software developers. Software developers are in charge of making the code work, for sure, but software engineers are in charge of organizing this code, of making it maintainable, of doing many things for the code that is sometimes not even visible except in the loss of productivity. So just to get back a little bit to it, there is a general definition of engineering that is on Wikipedia. So I took this one and I show it. And I'm not monitoring the questions. I saw that there were a few comments, right? So engineering is basically the practice of using natural sciences, mathematics, engineering design processes, etc., to solve problems within technology and to increase the efficiency and productivity and improve systems. And an engineer, in general, is to form a link between. Sorry, I have an end on my glasses. The work of an engineer is to form the link between scientific discoveries and their subsequent applications to human and business needs and quality of life. So if we think about the old case or the old definition of engineers, This is this kind of magical person who knows science enough to make things work, right? Where others have troubles because they try things, but it doesn't work. In the case of software, of course, it is much more blurry, right? The difference between software developers and software engineers is more difficult to establish because they have many features in common. For example, software engineers can code and developers can code as well. But the characteristic of a software engineer is that they add this scientific knowledge, right? And so if you're a software developer with a bachelor, you might have that knowledge already, but you might not be requested to apply it. So it's a question of role. It's not a question of person, right? There are places, there are countries where having the title engineer is actually very regulated. And I've lived in two of them, or three of them actually. So there's France, you need to come from a specific school, set of schools that give you an engineer diploma. So that's where I graduated originally, with an engineer diploma. And then I was in the UK. I think in the US, there's also the same as in the UK. You have a professional organization where you study an engineering diploma, and that gives you the legitimacy to, after a few years of practice, so of experience, to request the title engineer. And this title is actually tied to your knowledge of the engineering field. You pass in front of a board, you have to answer questions to show that you have enough experience and understanding of your field to be an engineer, to become an engineer and have the title. Unlike researchers and like developers, software engineers are focused on producing working systems, not just ideas, right? Because with research, some of the researchers, most of the researchers in software, they produce software, but still a number of them are producing theories. And theories are great, but they don't necessarily work, right? But the software engineers, they share with the researchers a systematic use of rigorous scientific and engineering principles, which the developers often neglect. So what that means is that your average developer will know how to code something, how to make things work, but they will not necessarily think about all the aspects. And this is shown here in some of the tasks that I assembled for software developers and software engineers. So for software developers, you see that writing code is really at the core, right? It's one of the things that you really do. Testing the code, following the processes, analyzing requirements. So you receive the requirements and then you analyze them and you think about how you're going to make them. Building applications, evaluating the feasibility of doing something, and releasing applications. This is the main core of, or the core of what software developers do. And software engineers, they tend to do other things. When they write the code or they write code, they usually focus on the critical parts of the code, the most difficult things from a theoretical perspective. And that is, for example, concurrency. How do you write properly concurrency code? Well, you need to understand the concepts, but not only, you need to have the practice and to be able to reason about it. So this is part of the difficulties that you have. Or it could be having some middleware. Creating the middleware is difficult, right? Other things that software engineers do is following and modifying processes, creating the architecture of the code. Then they are usually called software architects. But you have to remember that software architecture as software development is part of software engineering, right? Understanding and running static analysis tools, and sometimes writing them like I was doing in my example. Understanding the software quality, how to reach software quality. And in general, you see that you have devising software to be maintainable, but in general, it's tackling non-functional requirements. And if you don't remember, non-functional, or maybe for Will's education, if he doesn't know yet, non-functional requirements are the requirements where you cannot simply write a simple test or a set of simple tests to check them. So that's typically the requirements that have an ending in ility, right? Quality, maintainability, scalability, right? This kind of thing. And security, which is not in ELT, but in ET only. And these non-functional requirements, for you to get them, usually you need to have a much stronger understanding of the theoretical background. So, for example, if we talk about scalability, you will need to do, for example, calculations of the complexity of the programs, and see how it scales and make some evaluations about that. And defining how to make it scalable is what an architect is doing through something that is called the quality attributes, software quality attributes. So that's a different set of tasks, as you can see, even if there is some overlap. But typically, for example, at Google, you would have software engineers in test, which is a different role than software testers. The software testers would actually test the code one after the other, making some of the manual tests, but also launching the automated tests. And the software engineers in test would make the tools that allow you to actually test automatically, or suggest modifications of the code base so that it's more testable, right? So this is two different sets of tasks. So in short, software developers create the requested application with the proper domain knowledge, while the software engineers make the application for the next 20 years. And they are software specialists, right? And they work together. But if you see things in a job advertisement that are saying writing the code, knowing this specific stack, working on this and this and that, which is very close to the code, responsible for testing, then you see mostly the job description of a software developer. And if you have things that are about software architecture, making being responsible for the overall quality, or making sure that you have the right tool sets that are used, you're usually talking about software engineers proper. Right? One thing you might also realize is that you can have software developers follow a short program, a short education program, and then these developers are already developers after 6 months of work, right? While for software engineers, it takes a lot more, right? You probably need to go beyond the bachelor degree, because in a good bachelor degree, you would have one course on software engineering. But here, what we do at CIT is to offer a master's degree in software engineering and computer science. And you have half of the courses which are in software engineering, right? So, and then you tackle much more deeply this topic. Few examples of jobs for software developers: when you see full stack developer, front end developer, back end developer, and when they list things like Node.js and specific technologies there, usually it means that it's really a developer role. Embedded systems developers, data analytics developers, or data analysts usually. So these are jobs that are for developers, and they might be very, very technical. I have a very good question there that I just saw about AI. We will come back to this a little bit later. So what you see here is that you can have people who are very, very technically astute, right? But they are tied to specific technologies. And then that's why they ask you, do you know C? Do you know Java? Do you know, I don't know, Python, whatever is fancy these days, Rust. And in software engineering, you will have just the job software engineer, which sometimes is actually it's a wrong appellation for the job, and it can be a software developer. Software engineers in test, so it's a software engineer with a specialization in testing. Software quality managers, how do you actually make things good quality? Software architects, requirements elicitation engineer, right? This is a case where you really need to talk to people and to understand what they do, right? Product owners who will actually make the work items in Agile, right? So these are, and I could have added also project managers, software project managers. So these are more the jobs for software engineers because it requires you to be very strong in specific topics. Now, here's for your question, Mohammed. Because of the difficulty, so is AI impacting really software engineers and software developers? And in my understanding, they will both be impacted. So it's not as if, become a software engineer, otherwise AI is going to steal your job. No, that's not what is going to happen. What is going to happen is that developers will have to use more and more AI engines to make sure that they are more efficient. This comes with specific risks, which mean that if you're a developer, you need to validate the results and to verify the results by hand. So it means that you need to read the code that you commit. I was discussing not later than last week with a former student who is extensively using AI in the software development, in her software development role, software engineering role actually, but when she writes code, and she was telling me that she pushed some code that was wrong actually, because she didn't read properly the code and didn't understand it properly, and that's one of the risks, right? Things where AI will actually be much better or much quicker to use are things like using boilerplate code, making the first version of the code, adding comments, making documentation, creating test cases. And that comes to you, right? You asked, can you replace testing of the new developed apps in the near future? And the answer to this question is, to some extent, yes. So you can generate test cases, and if you called or if you named your methods and functions well, then the LLM will actually recognize that this has some meaning, and then will generate some test cases that are better or closer to what needs to be written. And if you don't do that effort, or if you have very complicated functions and methods, which a software engineer should actually tell you about, they should say, no, you cannot commit that method. It's too long. You need to cut it in pieces, etc. So if you have many more of those, if you have many of those, then the AI engines will have more difficulties creating the test cases. And in the end, you need to check also the test cases, because you need to make sure that whatever they wrote is actually correct, because it's your responsibility. Another question I have is, are software engineers or should software engineers have the knowledge about interdisciplinary fields across other IT domains like cybersecurity, DevOps, etc.? Yes, to some extent. When we talk about cybersecurity, for example, you have two types of, in my experience at least, you have two types of cybersecurity experts. One of them is looking at, let's say, Excel sheets and crossing or putting a tick in front of things of every line. And the other one is the other type, which is usually able also to do that, but prefers to code, is making the code properly so that you tick all the boxes already and you don't have bugs. And so the latter type is a software engineer in cybersecurity. And the former type is a cybersecurity tester, maybe, or expert. And yes, so if you don't want to make mistakes, you need to understand how to run DevOps, how to how to write securely your code. And if you don't do it, then you're in for big troubles. Because in the end, the software engineer is more responsible than the software developer on the results. That's what it means to be an engineer. When you have a civil engineer who is making a bridge, this person is responsible for the bridge not to fall. And at the moment in the software industry, we have managed not to be responsible too much for failures. But you can lose your job as a software engineer if you design the wrong architecture, right? For example. My recommendation to you with respect to AI is to acquire specialized knowledge. The more specialized you are on some topics, which don't have a lot of data to train an AI, the better for your job in the future. And what that means is things for which it's difficult to train AIs are things that need a judgment call from the engineer, needs experience to know that this will not fly. Simple things will be done by AI, will be judged by AI, but complicated things will not. And also very specialized things. So I mentioned, for example, embedded software developers. When you develop embedded software, then typically you don't have a lot of training data for that piece of software. So the AI engines will have difficulty generating the proper code. So if you are a software developer, then make sure that whatever you have doesn't have a lot of open source free data to use or even inner source free data to use. And that somehow you have a unique set of skills. And I think that's it from me. So I hope this has been useful. I'm, of course, happy to take further questions. So I don't know if we have more. Maybe
Thank you.
Will, you can tell me.
Yes, of course. And while we have a moment or two for people to type any additional questions that may come up, I thought of one related to your comment about risk, because you mentioned a couple of times the risk related to quality, of course, for any organization that's putting out software or developing internally for their needs. And you mentioned even the risk of the responsibility for software engineers, that there's a greater risk with a greater responsibility. Of course, that usually assumes a higher salary as well. So I assume that software engineers with more responsibility are also earning more. Do you see a risk for software developers who, as you mentioned, they've had training, perhaps not a full degree program, but they've had training, proper training in their to do the work that they're doing? Do you see a risk in terms of a plateau in their career because they've had the training, they're in the role, they're doing the role, but the dynamics around them will change? Is that right? It's my understanding is that it's so frequent now that retooling and retraining becomes an imperative. But is there a career risk for some people in the software developer role versus software engineers?
So the knowledge that you have as a software engineer is a little bit more portable because this is based on science and principles. Of course, you have to know how to code, but I'm almost 50 years old. I have had a career of 30 years at the moment, and I have changed or switched programming languages maybe 4 or 5 times easily, maybe more. And what I can tell you is I have seen, these very much older people who were developers, like PLC developers, or what did we have in the banking industry? COBOL developers, who have that training, that understanding of, and know how to develop these things. And they have worked for 20 years, and then at some point, something happened in their life. The company went bankrupt, and then they didn't have additional knowledge that they could actually activate. So of course they knew how to code, but it was very difficult because they had been formatted in the COBOL thinking. So my recommendation for people who work as software developers is to keep really, really sharp with the new trends. So if you want to be a software developer, that's great. I really enjoy development myself as a person. So, but you need to try new languages. You need to try to understand new concepts that are there. And you need to get closer to being a software engineer, except that you will code all the time and that will be your main activity. But you need to keep sharp. So I have a friend who just lost his job. And he's very good in SQL and information systems modeling and things like that. But I know that it's going to be difficult because he doesn't have to find another job because he doesn't have this understanding yet. He will need to learn it. But he doesn't know Python. He doesn't know full stack development. He needs to learn these things because he didn't keep up to date with his knowledge.
Yeah.
And so in all cases, in the case of software engineers, in the case of software developers, you need to keep developing yourself and learning over time. That is clear. But the software engineers have something that is a little bit more in temporal, right?
Mm.
So when you know very well object-oriented programming, then you know modeling, then you know how to make classes, you know how to organize your code. And this doesn't change very much. You have the same thing in Python, you have the same thing in C++, you have the same thing in Java.
Mhm.
So all this evolves a little bit better because you
Yeah,
have paid the price already once.
this makes
Um,
sense.
yeah.
And it, on the same theme, related to career risk and career choices, there was a question in the group also, and I can imagine, especially students that are in computer science, perhaps in a bachelor looking for further studies, making a choice between cybersecurity and data science, for example, different pathways where you can focus. And those choices are sometimes personal based on what's driving their curiosity, and sometimes it might be based on what they think is going to be the market for the
Yeah.
skills. But how do you coach some of the students that you've had when they have to make a choice between focusing in cybersecurity, focusing on AI, focusing in other, what is your
So
recommendation normally?
so my recommendation for in the case of so these are all different topics, right? In the case of AI, I think it's here to stay, and it will
Hmm.
be part of the standard tool set that any software engineer or software developer should be using. So AI will be something that you need to be able to interface with to understand the basics at least. In the case of data analytics, I think the you have people who do only data analytics. The problem they have, and this is really something that we have seen in practice, is that they have no idea what software engineering is. So you have masters in data science that train you how to train even some AI engines that train you on how to change the format of data, etc. But they don't train you on software engineering. And what that means is that a lot of these people, they develop something, but then how is it going to work in the next 10 years, 20 years, right? Do they have the right structures that will make it survive the next 10, 20 years?
Mm.
And that is the difficulty. That is the real difficulty. And this has been recognized. I'm not the only one to say it. Whether in AI or data analytics, and I used to be head of data analytics for part of the company. Um, we have seen that it was not a simple thing to get into the minds of the people because they had very, very, very little software engineering training.
Mm.
We have another question here, which is, should software engineers highlight tools on their CVs like software developers? So to some extent, yes. But I would rather, personally, I think the tools like programming languages and things like that make sense anyway, because it's part of the overlap between the software developers and the software engineers. Um, but I would go a little bit higher than that in general. So I would say OO programming, and then put some examples of OO languages that you know. And then I would actually also mention, if you know static analysis, then the tools that you have used in static analysis. But I would always label them with the kind of tools that we're talking about. So whether it's testing frameworks, and then I would give examples, static analysis tools, and I would give examples. Um, and I don't know what else, maybe agile methodologies and maybe the specifics, Scrum or whatever. Because that way it shows that you have more generalities, right? That you have more breadth in your training. It's not just very thin in one direction.
That's great. Thank you. I perhaps as a transition question, unless we have any others that pop up in the next minute or two, um, you also mentioned some of the business decisions that have to be taken based on the quality of products and services or internal software developed. And obviously, there's risks involved about managing quality and all. You and the other faculty have mentioned to me more than once that what you saw in industry sometimes are great technical graduates who don't have business acumen. And this is a question related to our curriculum, but for the candidates that are thinking about career and thinking about perhaps going back for additional training or learning, where have you seen the gaps, or where do you see the bigger needs between the business side and the technical side? of graduates, let's say young graduates or people even in their early 30s who might have had a degree, a first degree in computer science or something related. Um,
So,
it seems that there's a some of them are thinking, do I do an MBA? You know, there's lots of these kinds of questions that pop up.
so just for your information for the students, we haven't rehearsed that question at all. So,
No, it's
but that's so you will have my untainted point of view there. So what I have seen very often is not very often, but in some cases, very strong developers. In some cases, software engineers, but software engineers are more cautious in general with people because they have done software requirement solicitation. But I've seen a lot, not a lot, but maybe 10, 15 software developers that were so strong in their topic that they thought they didn't need to take into account the human factor. What that means is be nice with your colleagues. When they go for coffee and they offer you, you go there as well, you know? I have seen a number of them be insufferable. What happens is when they grow older, they have very much trouble taking up a new position, a new function, right? Because if you're this legendary computer specialist who can code in COBOL, but is insufferable, no one will promote you to group leader, right? And no one will put you in front of customers, right? So the problem is, what if suddenly no one needs COBOL anymore? Well, you're out. And that's the problem. We tend to have a number of people who are quite arrogant about what they do, what they say, how they say it. They think it's even positive to do it. It's not. So you need to have an understanding of how business is done so that you don't make the mistake of insulting the wrong people, of not understanding how to work with people. Because actually, at the end of the day, you know, any great product is at least made by 20 to 25 people, minimum. So if you're a part of the software development, you will need to interact with 20 other people. And being able to do that is a skill that gets acquired. Being able to understand what other people want is something that you can be trained on. And as you mentioned, Will, I mean, this is part of what we do in the master's programs because we have 25 to 30% of our courses which are on business, right, and on leadership and on management. And if you do that, then suddenly some things become clear, right? So, for example, a very simple thing. A lot of people in marketing are actually thinking in terms of job to be done, right? So they think, what is the job to be done so that I can offer a solution to my customers to replace whatever they do? Let's imagine you read 100, you're an HR specialist, you read 100 CV per day. How can I ease your pain? Because this is painful to read 100 CV per day. And then some people say, well, there is the job to be done. We replace that with an AI engine that will rank them. And believe me, this is what they have in HR these days. So understanding that this is an approach to take when you want to create this product that will help the people from HR, then is a skill set in itself, right? Trying to understand or to discover how people work, being able to ask them. So, you know, when I want to elicit this kind of requirements, I will go to someone and say, and chit chat with them. It doesn't look like productive work, but actually I learn a lot about how they make their work. The best people who also work with the UX, they will follow users, right? And the first few days, they know that the users will behave differently than later when they become friends, right? So, for example, if you work on an ERP, you know that people will actually lie to you as how it works in their company at the beginning. And then you will realize that some people can actually make the decisions, right? So they will say, well, this is the responsibility of the boss. Well, what happens if the boss is on vacation? well, the assistant can actually call the boss, or so you have a process that is actually different from what is announced on paper. And this is how you elicit the requirements. So being able to do that, to understand how businesses are created, how we actually make some kind of startups, for example, is some of the knowledge that we teach in the master's degree.
Thank you. That's a perfect transition. And I didn't see any other questions. There was a couple that were more specific to their individual cases, and I'll reach back to them by email, even perhaps after the session. What I'll do is, first of all, to say thank you for the insights, and some of that was very spontaneous. So thank you for taking
No
uh,
worries.
the spontaneous questions as well. Um, and I invite you to stay if you like, but there's, no obligations to stay for the presentation on the Institute itself. You can also be sort of silently behind the scenes if you want to. That's fine too. But for anyone again who's been attending, please feel free to review not only Professor Oriol's bio to look at his background more closely on our website, but also link to the research that he's been conducting in so many very interesting fields. He's leading a team of PhD students as well, and continuing to publish and lead the institution to the next stage of our growth. So what I'll do in the next 10 minutes or so is give you a teaser into the structure of the Institute and our programs, master programs in particular, and the pathway to the master programs. We have a pre-master for those who are coming from outside of computer science. And then the teaser is essentially to invite you back for a admissions open hour where I'm going to present a more detailed presentation and take questions there as well. So if you have questions and you want to continue typing in the chat as I go through this, please feel free. In the meantime, what I'll do is jump to the next slide. Just to briefly go over, for those of you that maybe didn't get a chance to review on our website, we have at the graduate level, the Institute is exclusively focused at the graduate level at this time. We have a pre-master program to prepare people for the Master of Science if they don't have a full degree in computer science or software engineering, the relevant skills, which means that some people from other engineering or other science and technology backgrounds, maybe even someone from business who has a very strong quantitative background who now does coding and got into programming, who wants to do a degree in computer science at the graduate level, could take the pre-master. So the two master programs that we're running are the Master of Science in Computer Science, Software Engineering, and Leadership. This is essentially the flagship program that the Institute began, combining both technical skills and business leadership, business acumen that is needed in the tech sector, whether it's in startups, as Manuel referred to, or if it's even within larger institutions, R&D, and so forth. We have a PhD program. This is for those interested in advanced research, and they're really doing research at the forefront in fields related to software testing, quantum, and so forth, and also some executive education for corporations in the region. Our Master of Programs, essentially as a philosophy, it's about 60% technical, 40% business, so management and leadership skills. A lot of the details are in the website, and I'll go through them next week at this time, next week for the admissions open hour. I want to highlight the capstone because this is a very practical course that most of the students that graduate say was their either highlight or favorite course of the program because it's a 3-semester experience. You heard Manuel mention that it takes something like 25 team members, staff members, company employees to put together a real robust product or service, a technology that's being rolled out to clients on behalf of a client need. This process of going through from the idea to testing the concept itself, to getting validation on that, to setting all the requirements for the client, going through the process of software architecture, all the way through to integrating aspects of AI and cybersecurity into the product, service, or technology that the students are developing. This is guided by a professor over 3 semesters. Students are working in a team. They're called a tribe. And this is basically our professor's way of simulating the life cycle of product development that they've seen in industry. That is really a great way to learn. If you have aspirations to be an entrepreneur for your own startup or to work in a startup, it's a great experience because you get to test out some of those skills that Manuel was referring to. the soft skills that sometimes are skipped and overlooked by some of the programs in technology at the graduate level. So for those people that might have thought, okay, I have a technical background in my bachelor and I'm thinking, do I need a business degree like an MBA? Our program is really a combination, a perfect combination for you to dive into the business side while advancing at the forefront in technology. To give you a sample of a few of our alumni, we have students here who graduated from Kenya, from Croatia, from Ethiopia, Russia, and India. They're all working in Zurich region, Zurich, Basel, Bern. They each had a degree in computer science before they joined. However, I want to mention that we also have students coming from physics, math, and other engineering areas who did the pre-master program before joining the Master of Science. And many students ask me, is the institute connected to companies? Do you get practical experience? Do you get exposure to business leaders? This is just a sample of some of the companies that actually came to the Career Day, which is a joint career day for Constructor with Constructor University in Germany. Our students participate either in person or remotely. And you see there's a variety of different companies, leaders in different technical areas looking for talent, either for interns or for graduates to hire. Constructor, just to give you a sense of where we are, the building I'm in, is a former tech startup, the home of Acronis, which is now a very well-established, a leading cybersecurity data storage, data protection, integrating AI into that, but a leading company in the industry. We are a brainchild of the same founder. And we're located in that same building. So we have a beautiful location. It's just about 10, 15 minutes from the city center if you're walking, and a 3-minute bus ride from Schaffhausen city center. I alluded to Constructor University. We are part of a larger group. If you look at Constructor online, you'll see that we have the university in Bremen, the institute here in Schaffhausen, which is at the graduate level, Constructor Academy in Zurich and in Munich now, which does training in full stack data science and similar areas in Python and so forth, tended to be shorter infusions of learning rather than a full degree program. The degree programs are with us at the institute here. We also have a program for high school students developing the interest in science and technology before they go to university. So next week, I'm going to present a little bit more during the admissions open hour about why choose Switzerland for your tech studies. And I know that for many people, when you hear about Switzerland, you think about banking, you think about all different sectors, whether it's the luxury industry, hospitality, the tourism. But in fact, Switzerland has been at the forefront in not only AI for many, many years, multiple decades already, and in technology, but also in quantum now, quantum computing, quantum research. And I'll refer next week to a few of the reports that have been produced on where Switzerland is relative to other companies, other countries, in terms of tech transfer, going from the research done in universities, spinning off into technology startups, the research that universities do on behalf of companies' current real-time needs, a lot of collaboration between industry and universities. And you see just examples of a few of them on the screen and some of the rankings of Switzerland's leadership in artificial intelligence. So both on the quantum side and artificial intelligence, Switzerland is also at the forefront. And just in our backyard, we are across the river from the Zurich canton. So we're only 40 minutes by train from the very center of Zurich. And you see a number of recognized companies here, from Sony to Google. All of the big names want to do research here in Zurich because the talent pool is what they're looking for. They're looking for access to the brightest minds in the region and from some different parts of the world who come to study here in Switzerland. As I mentioned earlier, we're new. We're about 6 years now as an institute, but we are essentially integrating already into the ecosystem of higher education in Switzerland. The idea is that we will continue to grow eventually, perhaps even at the undergraduate level, but for now focused at the graduate level, exclusively master's and PhD and that pre-master program. And there is a concerted effort in the Zurich region to continue to promote Zurich as like a Silicon Valley of Europe in many ways. Already it has established, Google has, I think, about 5,000 employees in the region. But there's a number of industries, whether it's banking and finance, pharmaceuticals, biotechnology, a lot of startups, all related, so using the same talent. And this is a great way to connect to companies and industry before you graduate through internships, through live projects. Next week, I'll explain also in our curriculum that your thesis can be either a traditional research thesis, it can be a project for a company that has an actual need for a product, service, or technology that you could develop. And finally, you can also do your own startup as your thesis. So guided by a professor, you can work on the same process that they lead the students through in the capstone course. You can do this on behalf of your own startup, your own concept, targeting a particular industry sector or need that you think could be a future unicorn, for example. So this is one of the great opportunities. Next week, I'll also go through the admissions, and everyone always asks, can we give at least the very basics on rates of tuition and so forth? This is a snapshot screen of our tuition rate and also cost of living. So for 1 year, it's about 50,000 francs, or about 50 something, 52,000 euros. However, as soon as I present our tuition, I want to remind everyone to think outside of the box when it comes to the official costs of the Institute, simply because we do have resources for and financial means through the foundation to support many students through reductions in fees in the form of merit scholarships. And so you have the opportunity to interview with professors for admission, but also to compete for potential scholarship support. Those go in the ranges of maybe a third, 2/3, up to a full tuition waiver for the most outstanding students. And the pre-master program is offered every year. If someone takes the pre-master, then any fees they pay for the pre-master get deducted from their Master of Science tuition. So all next week, I'll be going in further detail on all of this, the programs, the admissions process, the timelines, and so on. But I'll mention quickly again, the admissions process, it's all really simple for anyone who's thinking about this particular year. July 15th is our application deadline for those from within Europe. If you're outside of Europe, please make an application right away. Join us next week for the live admissions open hour to ask your questions. And we look forward to conducting the admissions interview very quickly. So I've mentioned the timeline. Those who might need a student visa, of course, it's critical to apply early, and that's why we typically put the deadline earlier in the year. However, we do have some spaces available for those students who predict to earn admission. If the visa comes a bit late, of course, you can arrive late because all of our programs are hybrid. They're delivered both face-to-face and online, which means that you can attend classes even while the final visa paperwork is in place. So again, why study IT? Why come to Switzerland and with us for your higher education? Feel free, please register. The QR code is here to join me next week. I'll be giving about a 20-minute introduction to some further details on the Zurich and the Swiss leadership in the region in software engineering, computer science, and related fields. And then I'll also introduce the programs in further detail. I'll talk about the admissions, and then there'll be Q&A related to the admissions process, scholarships, and the timelines, the expectations, everything related to housing, to life in Switzerland as a student. Individual questions that you may have would be welcome at that time as well. This particular webinar is designed broadcast style. The open hour is a meeting style, which means that you'll be able to unmute, ask questions informally with me. It's not a professor, but rather just I'm your coach and your guide in the admissions process, or even in the process just to explore studying for your master's degree. So again, register today if you'd like for the session we're having next week. And for any of you who are not able to join us at the same time next week, I'm certainly available for one-to-one Zoom sessions. I typically do them in about 15 minutes to 30 minutes. You can reach me by email through the website and book a time to connect, and we can just discuss your individual interests and goals. Even if you're just exploring the possibility. I've worked with dozens of students from around the world for many years. I'm in Switzerland now for 16 years, coaching and in higher education, coaching and mentoring students at all ages, from just graduating from bachelor all the way through to executive level, joining just to further studies here in Switzerland. So it would be a pleasure to connect with you one-to-one. So thank you again for joining us. If you're interested in taking a quantum leap leap in your life if you're outside of Switzerland, referring to relocating for your master's studies. If you're local, of course, then it would be great to have you visit and meet with us in person. And I could introduce you to a few of the recent graduates or current students, some PhD students who are always here around the year. Although we just finished our academic year, so the master's students have all gone home or to an internship. In the meantime, I'm just going to check to see if there are any final questions in the chat, but I think that was it for the Q&A on the topic of the day. And I invite you again to please join me next week for a deeper dive into the programs, the Institute itself, some of the technical elements that we look for in great candidates for our scholarship program. And for those of you who are thinking about going back for a study, for further studies in higher learning, either this year or in years ahead, please feel free to join us next week at the admissions open hour. Again, I'll go back to that QR code. Feel free, go ahead to take the QR code quickly and make a registration. It's also right on the website. If you find the events page on our Institute website, you'll be able to register, and we look forward to your participation next week as well. Thank you very much for joining us. I see that Manuel was not able to stay, but I thank him again for his insights coming from both academia and business. It's a great learning experience to study under a professor who has been in the trenches in industry, leading software development teams, leading innovation, embedded systems, Internet of Things. He has really extensive experience. And of course, now he's leading our chair in quantum technologies, which is quantum software engineering. So he's collaborating with the greatest minds in the region and leading student teams through the curriculum and developing, of course, our institute's larger vision. So thank you again to Manuel for joining us. Thank you, everyone, for being here on the webinar. I look forward to speaking with you individually or to welcome you back for next week's admissions open hour. All the best from Schaffhausen, Switzerland. Enjoy the day.